Good day. We are a Macaulay group, and this is lab activity number 11, generation of sinusoidal signal through filtering. So, LTI or linear time invariant systems are used for predicting long-term behavior in a system. It uses both linear and time invariant systems. Its outputs for a linear combination of inputs are the same as the linear combination of individual responses to the input. It produces an output signal from any input signal which can be focused on the constraints of linearity and time invariance. Filtering is the process of removing unnecessary components or features from a given signal. It is a signal processing process where it clearly defines the features of a signal and removes other features of the signal which are not defined or have met the conditions for the output signals. So based on the given code, what we did was clear, close everything first, and then we initiated or executed the vectors b, a, and n. So b is 1, a is 1, -1, and 0.9, and n is from -20 up to 120. T is from 0 up to 2 times pi with an increment of 0.1. X is the sign of T, and S is the filter of B, A, and X. So we use stem to plot the discrete sequence data T and S. The title would be Sinusoidal Response with an X label of N and a Y label of S of N. So as we can see on our given figure or output, the graph shows that the upward parabola has its data points, on which the first parabola was somewhat inconsistent, going upwards then downwards. This was caused due to the input A, which is the 1, -1, and 0.9. The third value of the input is 0.9, and it was closer to 1. So there seems to be an effect on the graph's data points causing inconsistency on the first parabola. So if the coefficient or the third value has a lower value, it will generate a more consistent shape of parabola. So in input A, the third value is 0.9, which may be a factor why the parabola look more inconsistent on its data points. So input A represents the coefficient, as what I've said, of the filter on this code, and there are other things that can be modified and give output changes, like the input B coefficient values or input signal value that could affect the output. So based on our results, we learned that sequences and signals application in the LTI discrete time system, and through manipulation of coefficients in the filters, whatever given input signal will produce a filtered sinusoidal signal. The output signal graphs are dependent on the tweaks on the filter's coefficients and input signal. So we tried manipulating the coefficient A. That's how we learned that it causes consistency and inconsistency. So this signifies that to get the optimum or desired signal output based on the provided signal, filters coefficients should be modified, especially to LTI systems. And that is all. Thank you.